Coulomb potential and the hydrogen atom. Here we have to find out the solution of the radial equation. In the previous class we uh, discussed the radial equation, that is minus h cross square by 2 mu d square by dr square plus 2 by r into d by dr plus l into l plus 1 h cross square by 2 mu r square plus v of r is into r is equal to er. And this can be written, I multiplied throughout this equation by minus 1, that's why this minus become plus here and this plus become minus here. Then E minus V into R is equal to 0. And I multiplied with the 2 mu by h cross square throughout the equation. Then we will get this equation and equation number 1. So this equation with the V of R is equal to minus Z E square by R is called the radial equation of hydrogen like atoms, and for hydrogen like atoms Z equal to 1. Now we can substitute V of R is equal to minus Z E square by R in equation 1. Then equation becomes d square R by dr square plus 2 by R into dr by dr plus minus L into L plus 1 by R square plus 2 mu E by h cross square. And instead of V, I substitute minus Z d square by R. So this minus become plus here. So plus 2 mu Z d square by R h cross square into R is equal to 0. So according to classical mechanics, a negative energy means E less than 0 corresponds to elliptical orbit, and E is greater than or equal to 0 corresponds to hyperbolic orbits representing unbounded state. In case of hydrogen atom, consider the electron in the bound state, that is E less than 0. Now substitute, we can substitute instead of minus 2 mu E by h cross square, it is alpha square. Alpha square is equal to minus 2 mu E by h cross square, and lambda is equal to mu Z E square by h cross square alpha. And lambda alpha is equal to anyway mu Z E square by h cross square. We can substitute this equation in 2. This equation. Okay. Now that equation becomes this one, that is equation number 3. Let us now introduce a new independent variable rho, that is rho is equal to 2 alpha r. Then d rho by dr is equal to 2 alpha. Then this dr by dr can be written as dr by d rho into d rho by dr. But d rho by dr is 2 alpha, so this one is 2 alpha into dr by d rho. And d square r by dr square is d by dr of dr by dr, which is equal to dr by dr into this dr by dr can be written as dr by d rho into d rho by dr. Now this equation becomes this equation, and we can apply the product rule here, and I applied the product rule, and instead of d rho by dr I substitute 2 alpha. Here also d rho by dr I substitute 2 alpha. Here also 2 alpha. Then that equation becomes 4 alpha square d square r by d rho square. So we can substitute the value of dr by dr, d square r by dr square in equation number 3. So instead of d square by dr square and dr by dr, we can substitute this equation. Then the equation becomes like this. Then this one, we have rho is equal to 2 alpha r. So r is equal to rho by 2 alpha. So instead of this r square r, we can substitute this value, r is equal to rho by 2 alpha. Then our equation becomes, this is our equation. If alpha rho tends to infinity, then equation 5 approaches the form, that is d square r by d rho square minus 1 by 4 r is equal to 0. So the solution of this equation is, r is equal to e to the power plus rho by 2, and r is equal to e to the power minus rho by 2. As rho may vary from 0 to infinity, the first solution is r is equal to e to the power rho by 2, will increase as rho increases. As rho tends to infinity, it will lead to an unacceptable wave function, because if rho rho increases, then the R it will increases. So if rho approaches to infinity, this solution also approaches to infinity, that will lead to an unacceptable wave function. On the other hand, the second solution it is e to the power minus rho by 2. So if rho increases, then R, that is R is equal to e to the power minus rho by 2. Uh, uh, it will decreases to 0, because e to the power minus infinity, that is 1 by e to the power infinity, is 0. So consequently, the second solution is a satisfactory solution. So the exact solution of equation number 5 is of the form R is equal to f into e to the power minus rho by 2, where f is another function of rho. So, okay, R is equal to f of rho into e to the power rho by 2. So dr by d rho is equal to, I differentiate this equation, then this equation becomes this one, and again I am differentiating this equation, that is d square r by d rho square. Then I'll get this equation. Then we can substitute the value of d square r by d rho square and dr by d rho and r in equation number 5. So in equation number 5, here d square r by d rho square, d r by d rho and r. We can substitute the equation, then the equation number 5, and I just rearrange this, and I'll get equation number 6. So let us find the solution of f of rho in the form f is equal to rho to the power s g rho, where g rho is a power series in rho beginning with a non-vanishing constant. So g rho is equal to summation k is equal to 0 to infinity ak rho to the power k, where g rho, then we can expand this form, then we'll get a power series, that is a0 plus a1 rho plus a2 rho square plus etc., where a0 is the first term is non-vanishing constant. It is a non-zero term, that is a0 is not equal to 0. Now we know that we took this function as f is equal to rho to the power s g rho, then I'm differentiating, so f prime rho and f double prime rho. Okay, then we can substitute the value of f prime and f double prime in equation number 6. So in this equation, f double prime, f prime and f. Okay, we can substitute these values, and we will get this. And we are dividing this equation with a rho to the power s, and the next equation is this one. Now I multiplied this equation with the rho square. So, and I multiplied this equation with the rho square, and just rearranging all these things, and I'll get equation number 8. So if rho is 0 in the above equation, then the equation becomes s into s plus 1 minus l into l plus 1 into g of 0 is equal to 0. From equation 7, we already wrote this equation, that is g rho is equal to summation over k is equal to 0 to infinity ak rho to the power 0. If rho is 0 means this part, it is the first part, a0, only a0. Other terms, yes, this g rho is equal to a0 plus, if all rho is 0 means this term will be cancelled, then we left with the first term a0. That's why g0 is equal to a0, where a0 is not equal to 0. Then equation number 9 becomes s into, so this g of 0 is not equal to 0 because it is equal to a0. Then this equal to 0, that is s into s plus 1 minus l into l plus 1 is equal to 0, that is s square minus l square plus s minus l is equal to 0. And I'm just rearranging all these things. Then we get this equation S minus L into S plus L plus 1 is equal to 0. Here S minus L is equal to 0, then S equal to L. If S plus L plus 1 is equal to 0, then S equal to minus L plus 1. So for S equal to L, this case, for S equal to L, the equation 8 becomes, we substitute the value of L instead of S in equation 8. Then the equation becomes this one. We have G rho is equal to summation K is equal to 0 to infinity AK rho to the power K, and G prime. Here we need to substitute the value of G double prime, G prime and G. Okay. And I find out the value of G double prime. We can substitute these values in equation number 10. Then we will get this form. And I just rearranging and dividing throughout by rho. Then I will get this equation. We have to equate the coefficient of rho to the K to 0. For that, I'm finding the rho. Here rho to the power K minus 1. Here also rho to the power K minus 1. So in order to make rho to the power K, just add plus 1. So here K becomes K plus 1. Okay. Then we can equate the coefficient of rho to the power K into 0. The next two equation. Just go through that. Then AK plus 1 is equal to K minus lambda plus L plus 1 by K plus 1 into K plus 2L plus 2 into AK. That is equation number 11. So this is this equation. Then if K tends to infinity, then AK plus 1 by AK is equal to 1 by K. And we have R is equal to F into e to the power minus rho by 2. So R is equal to, instead of F, I substitute the value. We know the value of F, that is rho to the power as 0. I substitute here. As rho increases, R also increases. To prove this, we consider the binomial series, e to the power rho binomial series. Then this equation AK plus 1 by AK is equal to 1 by K plus 1 factorial by 1 by K factorial. That is equal to K factorial by K plus 1 into K plus 1 minus 1 factorial, which is equal to 1 by K plus 1. If K is very large, then 1 can be neglected. Then AK plus 1 by K is equal to 1 by K. Thus, the series for f of rho for large values of rho behaves like rho to the power s e to the power rho. The function r for large values of rho will behave like this, which approaches to infinity. Thus, making the wave function is unacceptable. Thus, the series given by equation 11 does not lead to a satisfactory wave function. So we have to add some restrictions. Some restrictions need to be introduced, which makes the series break into finite number of terms. The series will break off after rho to the power k if numerator of equation 11 equals to 0. So what is number equation? This. Then the numerator k plus L plus 1 minus lambda is equal to 0. From this, lambda is equal to k plus L plus 1, which is equal to n, where k is called radial quantum number. K is equal to 1, 2, 3, etc. And n is the principal or total quantum number, that is n is equal to 1, 2, 3, 4, etc. And we have the lambda is equal to mu z d square by h cross square alpha, and alpha square is equal to minus mu e by h cross square. Since mu is equal to lambda, we can instead of lambda I wrote n. N is equal to mu z e square by h cross square alpha, that is n square is equal to mu square z square e to the power 4 by h cross square alpha square. So instead of alpha square, I substituted the value here. Then n square is this value. From this we can find out the energy. E is equal to this one, and which is equal to minus 13.6 electron volt by n square. Minus 13.6 by n square electron volt. So E is equal to h nu, that is E initial minus E final. H nu is nu can be written as C by lambda. So HC by lambda is equal to E initial minus En final. So from this 1 by lambda is equal to this one, and here okay, this value I substituted this value, and here there is one n square. So this is this value into 1 minus n initial square minus n final, that is n is the principal quantum number. So this is about the hydrogen atom wave function and the solution of radial wave function.